Okay, today we have the derivative of inverse trig functions, but let's first restart your memory by dealing with inverse trig functions. So first trig function is the inverse sine function. Remember that inverse sine lives from negative pi over 2 to pi over 2. So if I were to use this unit circle here, the inverse sine function would live here from negative pi over 2 to pi over 2, which means it lives in the first quadrant and the fourth quadrant. So in here. Okay. And of course, you would take these coordinates and just flip them over to the fourth quadrant. So this would actually be negative pi over 6, negative pi over 4, and negative pi over 3. Okay. So that being said, let's look at number 1. It says evaluate the inverse sine of negative 1/2. So remember, to do these type of evaluations, it would involve the inverse. So we would say let theta equal the inverse sine of negative 1/2. Then you would compose both sides with the inverse of the inverse, which is the sine function. So then you would have sine of theta equal to negative 1/2 on the restriction negative pi over 2 to pi over 2. So all you would have to do now, is find out what value of theta on this interval of negative pi over 2 to pi over 2 would give you negative 1/2. And if we look at the unit circle I just drew, where in quadrant 1 and in quadrant 4 is my y value negative 1/2? Or I guess I should just say where, at what radian value in quadrant 4 is my y value negative 1/2?
Negative pi over 6.
Negative pi over 6, and that would be it. So here we would say theta is negative pi over 6. That's it. Because remember, with trig functions, it would usually be the sine of pi over 6 is 1/2. But now, since it's an inverse, you say the inverse sine of negative 1/2 would be negative pi over 6. So it's just inverse.
So this is like going back to pre-cal almost.
Exactly. I'm just jogging you. I'm just jogging your memory. And the only reason I'm doing this is to get us set up to help find the derivative of an actual inverse trig function, because finding the derivative of an inverse trig function deals with restrictions of inverse trig functions. So here, this is just refreshing your memory. And on your homework, there may be some actual pre-cal questions like these. Okay, number 2. This says evaluate the tangent of inverse sine of 1/3. How much can I zoom in? There we go. So for these problems, we would make a substitution. We would let theta equal the inverse sine of 1/3. Then you would compose both sides with the inverse. So you'd get sine theta equals 1/3 on that interval negative pi over 2 to pi over 2. So for this type of problem, since we made a substitution, tangent of inverse sine of 1/3 now becomes the tangent of theta. So theta now holds all this information. Well, if we look at our unit circle, nowhere on the normal unit circle can we find a y value of 1/3, which means in order to solve for this value of theta, we need to create a triangle in the correct quadrant. So based on this, since the inverse sine function lives from negative pi over 2 to pi over 2, and I'll just put 0 there, and we got a positive value of 1/3. Am I in the first quadrant or fourth quadrant?
First.
First, good. So here would be my right triangle. Here's theta. And if sine is 1/3, remember that sine is opposite over hypotenuse. So this means that you'd have 1 for your height, 3 for your hypotenuse, and then by the Pythagorean theorem, you'd get 3 squared minus 1 squared. So 9 minus 1 is 8. The square root of 8 is 2 square root of 2, which means that we can now answer the evaluation. It wants to know what is the tangent of theta. So now this theta holds all this information. So now we're calling on that theta and applying tangent to it. So from this triangle, we say the tangent of theta, and remember that tangent is opposite over adjacent. So this tangent of this theta would put 1 over 2 square root of 2. Or if you rationalize, what will we get?
Square root 2 over
Square root
2.
2 over 4.
That's my bad.
You're good. All right. And there you go. There's a little pre-cal refresher. Guys, remember that stuff? No.
Yes.
Okay, cool. So I just wanted to go over that, which will bring us into the derivative for the inverse sine function. So we're going to use similar methods to find this derivative. Okay. Since the sine function is continuous, this means that its inverse is also continuous. And if you are a continuous function, this means you have a derivative. So if there's a derivative of the sine function, then there's definitely a derivative of the inverse sine function. So I'm giving it to you already. The derivative of the inverse sine function is 1 over 1, the square root of 1 minus x squared. And the chain rule derivative of the inverse sine function is going to be u prime over the square root of 1 minus u squared. But what we're going to do on the next example is just prove where this derivative comes from. Because if you ever needed help remembering these derivatives without looking at a chart, well, now you know how you could create them. Okay. So proof of the derivative of the inverse sine function. So step 1, let y equal the inverse sine of x. So we'll just run down these steps. So step 1, y equals the inverse sine of x. And then step 2, apply the inverse to both sides. So step 2, you'll get sine of y equal to x. But this can only happen on the interval negative pi over 2 to pi over 2, because that's where the inverse sine lives. Okay, so what we're going to do next is create a triangle based on this ratio for sine. So since sine of y equals x, we can change x into a fraction. You can make x into x over 1. Which means if we were to plot this on the unit circle for the inverse sine function, since x over 1 is positive, this of course means that we are in the first quadrant. And my angle is now known as y. So sine puts opposite over hypotenuse. So this means that you would get x for your height and 1 for your hypotenuse. Okay, now you are going to use the Pythagorean theorem to find the base. So you would have the square root of 1 minus x squared as your base using the Pythagorean theorem. So this would become the square root of 1 minus x squared. Okay. The next thing we're going to do is solve for the cosine of angle y. And this will come in later, don't worry. So go ahead and find the cosine of angle y. So cosine of this angle of y will put adjacent over hypotenuse. So this means that cosine of y gives me the square root of 1 minus x squared. Okay, so now we have the cosine of y. The next thing we're going to do is take the implicit derivative of sine of y equals x, and we're going to solve it for y prime. So that's going to be step 3. We're going to say d over dx of sine of y equal to x. And the implicit derivative of sine of y is going to be a chain rule implicit. So you're going to get cosine of y times y prime equal to 1. And now we're going to solve for y prime, which means we divide by cosine of y. So this will give me 1 over the cosine of y. And now, do we actually know the value of cosine y? What is it?
Square root of 1 minus x squared.
There you go. And there we have it. There is the derivative for the inverse sine function. So y prime is now going to just be the derivative of the inverse sine of x is 1 over the square root of 1 minus x squared. Bam and bam. And that's where that derivative comes from, y'all. See, that's not too hard to prove, right? All right. Any questions on that process?
You're going to post this, right?
Yeah.
Okay, my internet just cut out completely.
Oh my goodness. Don't worry, we're gonna do one more. How's your internet now?
I can't tell the future, so who knows?
Okay. So now we're gonna prove the derivative for the inverse cosine function. So the inverse cosine, remember, it lives between 0 and pi. So we're gonna use those restrictions to help us find that derivative, to help us prove that derivative. Okay. So the derivative of the inverse cosine function is almost like the sine, but it's going to be -1 over the square root of 1 minus x squared. And that chain rule derivative is going to be -u prime over the square root of 1 minus u squared. So we're going to prove this derivative using these same methods. So step 1, we let y equal the inverse cosine of x. Step 2, we apply the inverse to both sides. So you'll get cosine of y equals x on the interval 0 to pi. And then step 3, we create that triangle. So you'll have cosine of y is equal to x over 1. And when I make this triangle, remember that the inverse cosine lives from 0 to pi. So 0 pi, there's pi over 2. And since cosine is equal to x over 1, which is positive, this means again we'll be in quadrant 1. So here's my angle of y. And now cosine puts adjacent over hypotenuse. So you'll get a base of x, a hypotenuse of 1, and by Pythagorean theorem, the height is going to be square root 1 minus x squared. And what we're going to do here is now solve for the sine of y, which will come in later. Sine of y is going to put opposite over hypotenuse. So square root 1 minus x squared. Okay, there's our whole setup. Now we're ready to find the derivative. So 4. Say d over dx of the cosine of y equal to x. And again, another implicit chain rule. The derivative of cosine is going to be negative sine y times the implicit derivative of y with respect to x, which is y prime equal to 1. Solve for y prime, divide by negative sine y, and y prime equals negative 1 over the sine of y. And now make a quick substitution. What is the value of the sine of y?
The square root of 1 minus x squared.
There you go. And now here is the proven derivative for the inverse cosine of x. So we can now write it as such. D over dx of the inverse cosine of x is equal to negative 1 over the square root of 1 minus x squared. And there it is. Proven by trigonometry and calculus. Any questions on that? And again, I show you this because you're probably going to have to do it in your homework. All right. Everybody good? All right. So that's how you prove an inverse trig derivative. Use trig and calculus together. And now the fun begins. Here is a table just for you to reference when doing inverse trig derivatives. It has the regular derivative and the chain rule derivatives. So we will be referencing this when working out the following derivatives. Oh man, I lost a bunch of people. All right.
Yeah, you're just calling it quits.
They're like, I'm done. All right. They're like, I don't have to remember this section. Okay. So we have the 6 derivatives for the 6 inverse trig functions. So just reference this chart when we start working. So number 1, let's find the derivative of x times the inverse tangent of the square root of x. Oh, these are so ugly. Okay. So since it is x times the inverse tangent of the square root of x, we are going to use the product rule on this one. So let me zoom in. Yeehaw. All right. So f will be x, and then g. Actually, yeah, different. G will be the inverse tangent, and I'm going to rewrite this as, of course, x to the 1/2. Okay. Derivative of x, that's the easy part. That's 1. Derivative of g. Now this is going to use that chain rule derivative for the inverse tangent of u. So keeping it simple, it's derivative of the inside over 1 plus the inside squared. Okay. So we'll follow that. Let me see. I'll keep it up on that screen. There we go. So, like I said, derivative of the inside, which is 1/2 x to the negative 1/2 over 1 plus the inside squared. Okay. Of course, we have some cleaning up to do. This will become 1 over, and we can bring that 2 down, that 2 and that x to negative 1/2. So this would be 1 over 2 square root x times 1 plus x. That's as clean as we can get it. And then finish up our product rule. So let's say f prime of x, f prime g, which is just the inverse tangent of x to the 1/2, plus g prime f, make sure to use the simplified form, and you'll get x over 2 square root x times 1 plus x. Okay, now there's the derivative, and let's see if we can simplify more. This inverse tangent function is done, but this fraction, we can do one more step. Does anybody see what we can reduce?
Do you have to distribute first?
Nope, do not.
Nope.
If you distribute, then we're not going to be able to reduce anything. So
No.
leave it as it is. So right now, the denominator is all connected by multiplication. So I can reduce this x with which x?
X plus 1.
Can't do that one because this is trapped inside the parentheses. So our only other option would be the square root of x. Because this looks like x over x to the 1/2. So this is x the first power. If I reduce those, what would I get?
X to the 1/2.
X to the 1/2. There we go. Which means that my final answer is going to be tangent, inverse tangent, and I can rewrite that as the square root of x plus the square root of x over 2 times 1 plus x. Distribute that 2 if you really want to. I told you, these are ugly. Okay, any questions on that? Breathe it in, soak it in. Everybody good? Oh, got a thumbs up. All right, good. One thumbs up. Okay, that means let's move on. 2, y equals the inverse tangent of x squared. Again, this is going to use the chain rule derivative for the inverse tangent function. So this means that we are going to get, move that down a bit. We'll get y prime equals, and the chain rule derivative for the inverse tangent is going to be the derivative of the inside. So the derivative of the inside over 1 plus the inside squared. And we'll just end up with 2x over 1 plus x to the fourth. Can't do anything else there. That one's actually nice. Okay, there's the first page. Everybody good? We'll keep trucking through these. All right, then.
So you don't do anything with the inverse tangent on this one?
Well, remember that the inverse tangent becomes this formula.
Oh, okay.
So there is no longer a trig function attached to it, right? In the actual derivative. Because by our derivative proofs, remember that we use triangles in the unit circle. So it all becomes a formula in itself.
Okay.
Okay. 3, y equals the inverse tangent of x squared. So this is going to be chain rule. So this means that we're going to get y prime equals, that 2 comes down. The inside stays the same. You now get that power of 1. So there's the derivative of the outside. And then we multiply it by the derivative of the inside. What is the derivative of the inverse tangent of x?
One over 1 plus x squared.
There you go. 1 over 1 plus x squared. Okay, cleanup time. All we have to do is multiply straight across, and we'll get 2 inverse tangent of x over 1 plus x squared. Done. So the tangent ones actually look nice. All right, let's keep moving. Is that 3? That was 3. And 4. All right, good. Another ugly one. All right, g of x equals the square root of x squared minus 1 times the inverse secant of x. So again, this is going to be a product rule. Product rule with definitely a chain. So here's going to be f, x squared minus 1 to the 1/2. And then here's g, the inverse secant of x. Take the derivative of f, chain rule, 1/2 times x squared minus 1 to the negative 1/2 times the derivative of the inside, which is 2x. All right, let's go ahead and clean this up before we find g prime. And so if we clean this up, you get 1/2 times 2x. That means the x will come out on top, and you can flip the square root down. So we're going to get x over the square root of x squared minus 1. All right, that's f prime cleaned up. Now g prime. What is the derivative of the inverse secant function?
1 over x square root x squared minus 1.
Good. 1 over x times the square root of x squared minus 1. Perfect. That was the only easy one, right? And now we can finish our product rule. So g prime of x is going to be f prime g. So that'll be x times the inverse secant of x over the square root of x squared minus 1 plus g prime f. So that's going to be x squared minus 1 to the 1/2 over x times the square root of x squared minus 1. Now, nothing to simplify here. That's done. But we can definitely simplify this second fraction. What cancels out?
The square root of x squared minus 1.
So gone, gone. And our final answer is x secant inverse of x over the square root of x squared minus 1 plus 1 over x. Done. Any questions on number 4? Ooh, so many. Okay. 5. Inverse sine of 2x plus 1. This is going to use the chain rule derivative for the inverse sine function. So we're going to get y prime, and the chain rule derivative for the inverse sine function is going to be the derivative of the inside. So 2x plus 1, the derivative of the inside, 2 over the square root of 1 minus the inside squared. All right, now cleanup time. All right, because we just can't leave this guy like that, we have to expand and see what happens. So here we'll get 2 over the square root of 1 minus, and that is 2x plus 1 times 2x plus 1. Foil that out. And you get 2 over the square root of 1 minus 4x squared. What's that? 4x squared, 2x, 2x. 4x plus 1. Distribute that negative, and you get 2 over the square root of 1 minus 4x squared minus 4x minus 1. Where on the inside, your 1s will cancel. Where are we? Back here. I have the room. So now we have 2 over the square root of negative 4x squared minus 4x. What number could I factor out that I could take the square root of?
You can factor out the 4 and then take the square root of it.
Good. So this will become 4, square root of 4 times negative x squared minus x And now since the denominator is connected by multiplication inside the radical, I can separately take the square root of 4, which is just going to be 2 over 2 square root negative x squared minus x, where our 2's cancel. Oh boy. And you're left with 1 over the square root of negative x squared minus x. Nothing else we can go from there. Unless you wanted to rationalize it, but no. All right. Algebra, 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 right? Okay. Everybody good with that one? Thumbs up. Good. Okay. Next one. 6. Y equals the inverse tangent of x minus the square root of 1 plus x squared. So definitely chain rule of the inverse tangent function. But before we do any derivatives, let me rewrite it. Y equals the inverse tangent of x minus 1 plus x squared to the 1/2. And now we are ready to do the chain rule derivative for the inverse tangent function. Oh boy. So this means that y prime is going to be the derivative of the inside, which also involves a chain rule. So that's going to be 1 minus, and then you're going to chain rule 1 plus x squared to the 1/2. So you'll get 1/2 times 1 plus x squared to the negative 1/2 times 2x. There's the derivative of the inside. And now we put this all over 1 plus the inside, the original inside. I'm going to put brackets, be neat. X minus 1 plus x squared to the 1/2 squared. Oh boy. Lots of cleanup now. Okay. So that 1 is going to stay there. And then that 1/2 and that 2x will reduce to x times 1 plus x squared to the negative 1/2. We'll leave that alone for now. Over, oh man, yeah, we're going to have to FOIL that out. 1 plus, now leave it as brackets, x minus 1 plus x squared to the 1/2 times the same thing, x minus 1 plus x squared to the 1/2. Okay. Let's go ahead and FOIL that denominator. Numerator we'll leave alone for now. 1 minus x times 1 plus x squared to the negative 1/2 over 1 plus, and that's going to give me x squared minus the same thing. So you're going to get minus 2x times 1 plus x squared to the 1/2 plus 1 plus x squared to the 1/2 times 1 plus x squared to the 1/2 is just 1 plus x squared. Oh boy, breathe it in. Here's what we got so far. Okay. And now clean up the denominator. Numerator stays the same. 1 minus x to the 1 plus x squared to the negative 1/2 over, and over here, I have 1 and 1. So we're going to get 2. Well, what could I put up front first? That's fine. That'll be 2. And then x squared and x squared. Minus what's left over. 2x times 1 plus x squared to the 1/2. Oh, good times. Oh, almost there. Okay. So now, the only thing we could do in the denominator is take a 2 out now. And then in the numerator, so yeah, we'll go from there. So the numerator, I'm now going to make 1 minus x over the square root of 1 plus x squared over, and I'm going to take that 2 out of the denominator, put a bracket to be neat, and put it in highest power to lowest power. I'll have x squared minus x times 1 plus x squared to, actually, why not just write it as the square root of 1 plus x squared plus 1. Okay. And then the denominator is done. Nothing else we could do there. What we're going to do next is get a common denominator in the numerator. So I'm just going to put this over 1 and multiply by the square root of 1 plus x squared. So this will give us, in the numerator, square root of 1 plus x squared minus x over square root 1 plus x squared over that same denominator. Isn't this fun? And all we have left to do is take this denominator and bring it down. And we can't do anything else after that. You'll get square root 1 plus x squared minus x over 2 square root 1 plus x squared times x squared minus x times the square root of 1 plus x squared plus 1. Yee-haw. Ooh, man. Glorious.
Why wouldn't you cancel the square root 1 plus x squared?
Where? Oh, these two?
Yeah, those two.
You tell me why I can't.
Is it because the 2?
Nope.
Is it because of the minus x?
Very good. Since this is connected to the minus x, they are holding hands, and Red Rover cannot come over.
For sure.
You're such an idiot.
Hey, it makes sense. If they were connected by multiplication, if it was x times the square root of 1 plus x squared over 2 square root 1 plus x squared, then yes, but not the case.
It's when you're multiplying, right? It's because it's an add or subtraction. It wouldn't make it possible.
Exactly. Oof. All right. Probably no questions on that one, huh? Yep. All right, everybody good with this one for now?
Until I have to do it on my own. Yeah.
So you have to do it on your own. Don't worry, it's just algebra.
I hate algebra. Okay. I mean, you probably could keep going. You could distribute that denominator, and then that would cancel that. It would just make a mess of things. We're done. Ooh, all right, 7. Yeehaw. Square root of 1 minus x squared times the arc cosine of x. So again, this is another product rule. So here's going to be f 1 minus x squared to the 1/2. And g, arc cosine is the same as the inverse cosine of x. Both are the same. So why write it that way?
To throw students off,
Okay.
right?
No, seriously, I'm just curious.
No, yeah. They both mean the same thing. Arc cosine and the inverse cosine. The only time I ever see arc cosine, though, is on those terrible, terrible Casio calculators. Gross. Okay. My hate for Casio. All right. So take the derivatives, and 1/2 times 1 minus x squared to the negative 1/2 times negative 2x. Let's go ahead and clean this up. That 1/2, that negative 2x, we get negative x over the square root of 1 minus x squared. There's f prime. Okay. Now, somebody give me the derivative for the inverse cosine.
Negative 1 over the square root of 1 minus x squared.
There you go. That was the easiest part, right? Okay. So now finish up our product rule. F prime G, which is going to be negative x inverse cosine x over the square root of 1 minus x squared plus G prime F Oh, those arrows look terrible. Ooh, there we go. All right. And then that should give me negative 1 minus x squared, which we can probably already rewrite as negative square root of 1 minus x squared over square root 1 minus x squared. And now, Cole, what can you do? Did he leave?
He left.
He left.
Yeah, he's at
Af-
Hills and Dales.
Oh, great. After asking that question, okay. Well, everybody else, we can do what?
Cancel.
Cancel. And we'll get -1. Way to ask a question and dip, huh?
Yeah.
Okay, there's that. Not much we can do after that. All right. Let's keep moving. Arc sine of the square root of sine theta. Ooh la la. So again, quick little rewrite. F of theta is going to be the inverse sine. I'm going to put a lovely little bracket here because you have the square root of sine theta. So this is going to be sine theta to the 1/2. Okay, and this will use the chain rule derivative for the inverse sine function. So this means that we're going to get f prime of theta equal to the derivative of the inside. So we got a chain rule within a chain rule. So we're going to have 1/2 sine theta to the -1/2 times the derivative of the inside function, inside function, right? Which is cosine theta. There's the derivative of the inside function. Now we put it all over the inside function, well, sorry, the square root of 1 minus the inside function, brackets to be neat. Sine theta to the 1/2 squared. So 1 minus u squared. Okay. And cleanup. Let's see. The numerator. Yeah, we can work with both at the same time. So the numerator becomes cosine theta over 2 square root sine theta. That's the numerator. And then the denominator, square root 1 minus, and sine theta to the 1/2 squared, the exponents cancel, and you get 1 minus sine theta. Okay. Now, just like that crazy other one, this denominator, the denominator in the numerator will come down. So we get cosine theta over 2
square root sine theta times square root 1 minus sine theta. Okay. Now, can I combine those radicals?
I'm gonna say no.
Well, are they the same type of radical, like power-wise?
Yes.
Yes. So I can definitely put those radicals together, which means we're going to get cosine theta over 2 times the square root of sine theta times 1 minus sine theta. And not much we can do there. If you distribute the sine, you'd get sine minus sine squared, which is 1 minus cosine squared, which would do nothing for us. So that one is done. Told you guys, ugly. All right. More. Ooh, this one's good. All right. 9. G of x equals the inverse cotangent of x and the inverse cotangent of 1 over x. Okay. Quick little rewrite here. Well, not too much. We know that 1 over x just becomes x to the negative 1 on the inside. Okay, so now we're ready for the derivative, which means that g prime of x, what is the derivative for the inverse cotangent of x?
Negative 1 over 1 plus x squared.
Negative 1 over 1 plus x squared. Plus, now we need the chain rule derivative for the inverse cotangent. So what is the derivative of x to the negative 1?
Negative x to the negative 2.
Negative x to the negative 2 over 1 plus, well, actually, we are missing. So that's negative, but the inverse cotangent also has a negative involved. So hang on. Oh, where can I put that? So there should be a negative out front as well. There we go. Or else we'll mess things up. Over 1 plus the inside squared. Okay. So now cleanup time. And the first fraction is fine. Negative 1 over 1 plus x squared plus you get x, positive x to negative 2 over 1 plus x to the negative 2. So we need to fix this fraction, simplify it. So what could I do with that x to the negative 2?
The one in the numerator, bring it to the denominator.
There you go. So you get 1 over x squared times 1 plus x to the negative 2. We still need to fix. So this time you'll distribute that denominator. And you'll get 1 over x squared plus, and what is x squared times x to the negative 2 going to be?
X to the power 0, which
Is
is
it 1?
1.
Which is 1. Good. And now you have negative 1 over 1 plus x squared plus 1 over x squared plus 1. What is my answer?
0?
0. Easy, right? All of that for 0. Okay. Any questions on that? Inverse trigs, all the fun you could possibly have, right? Okay. 10. Y equals the inverse cosine of the inverse sine of t. All right. I hate using t, but whatever. So this is going to use the chain rule derivative for the inverse cosine. So if we start, we get y prime equals the negative derivative of the inside. So negative 1 times, and what is the derivative of the inverse sine of t going to be? Just pretend
1
t is
over
x. Good.
1 over the square root of 1 minus t squared.
There you go. There's the derivative of the inside function. And now we put it over the square root of 1 minus the inside function. Just use my brackets. Squared. Okay. And not much we can do here other than bring this denominator down. And we'll have negative 1 over the square root of 1 minus t squared times the square root of 1 minus, maybe I can use, let's see, inverse t squared. And the last thing we could do here is just combine the parentheses. Yeah, that's what. So you're going to get negative 1 over the total square root of 1 minus t squared times 1 minus the inverse sine of t squared. And sorry, it doesn't get any prettier than that. Woo. T's are the worst. Okay. All good on that one? All right. Dun, dun, dun. 11.
y equals the arctan of the cosine of theta. So again, quick rewrite. Inverse tangent of the cosine of theta. And this will use the chain rule for the inverse tangent. Okay, so we're going to have y prime equals the derivative of the inside. So what is the derivative of cosine?
Negative sine.
Negative sine theta over 1 plus the inside squared. Okay. And then that becomes negative sine theta over 1 plus cosine squared theta. Can we go further?
Yes, yes, I think we can.
Could we? Let's see if it works out. What could we change cosine into? Or cosine squared? Let's see if it helps or not. You get 1 plus, and what's cosine squared?
1 minus sine squared.
1 minus sine squared. Wow. 1 minus sine squared. And that would be negative sine theta over 2 minus sine squared. So did that do anything for us?
Yes.
It
Oh,
changed
well,
it, but I guess when I'm asking in a way of simplifying, did we reduce anything?
no.
No. Worth a try though, right? It's always good to think like that. So this is going to be our answer, and this is an equivalent answer. Right? Nothing after that? I don't think so. Let's see. Or by identities. First one's fine though. Okay. Right. Okay. Oh boy. Just throwing all these out there. All right. Next is x times the natural log of the arctangent of x. Once again, quick rewrite. X times the natural log of the inverse tangent of x. Okay, so this is going to be product rule again. F will be x, and g will be the natural log of the inverse tangent of x. All right, first one's easy. F prime is 1. Second one, we have to do the chain rule derivative for the natural log. So remember, the chain rule derivative for the natural log is derivative of the inside over the inside. So what is the derivative of the inverse tangent function?
One over 1 plus x squared.
1 over 1 plus x squared over the inside of the inverse tangent of x. And then just move that denominator down, and you'll have 1 over the inverse tangent of x times 1 plus x squared.
finish our product rule. F prime of x, f prime g, natural log, inverse tangent of x, plus g prime f, x over inverse tangent of x times 1 plus x squared. And I don't think we can do anything on that one. Nope. That one will be ugly as it is. Okay, all good. All right. Last one. Woo. I think it's the last one. 13. Let's see. Yep, no more. All right. 13. Y equals x times the inverse sine of x plus the square root of 1 minus x squared. All right. So first one, we'll use a product rule. So there's f, and then there's g. Derivative of f is 1. Derivative of g, what is the derivative for the inverse sine function?
1 over the square root of 1 minus x squared.
Good. And now for this derivative, for the first part of it at least, y prime f prime g inverse sine of x plus g prime times f x over the square root of 1 minus x squared plus, so product rule's done. Now we must do the derivative of square root of 1 minus x squared, which if we rewrote it would be 1 minus x squared to the 1/2. And that derivative would be 1/2 times 1 minus x squared to the negative 1/2 times negative 2x. So chain rule derivative of that one, which means cleanup, and we get sine inverse of x plus x over the square root of 1 minus x squared plus, and for cleanup, 1/2 negative 2x gives me negative x over the square root of 1 minus x squared. And what's going to cancel?
The x's over that, yeah.
The x is over the square root, and our answer is just the inverse sine of x. Crazy. And those are inverse trig functions. My goodness. Love them, hate them, love them.